Okay, so this is topic 6 on the stormwater drainage. So we have covered a long way lah regarding for our building, but this is only part 1 of our building science and services lah. So we have covered lighting, noise, heat, insulation, and then water supply, sanitation, and then finally it comes to storm drainage. So storm drainage actually have two components lah. There's actually internal and external. So when it comes to external, is a picture of what you see here, which is outside your house. And then when it comes to internal, then it's actually connected lah, or it's actually your sanitary appliances. So that's actually also removal of water lah in the house. So there's actually just a few item, which is only learning a bit of what is a fundamental, and then the different drainage system, and then what is the public. So storm drainage is actually also let's see, it's actually also divided into two, which is property and public. So when it comes to property, you have a small drainage, and then when it comes to public drainage system, then we actually have a very very big drain or culvert lah, where all the water is diverted towards a culvert, and then in a city we have a big culvert that goes through, and then finally we move it towards the river lah. So because when we develop a city, we cannot always have a natural river flowing through our city. So if we have a natural flowing river going through our city, then it will not be very good because it is natural. And then when rivers flows naturally, they will have erosion of soil, and also they will have changes in their flow. So one day they can be flowing in, let's say we have a city here, we have a building here. So one day they can be flowing here, and then another day, due to changes of water and wind, and then also erosion, they can have a change in flow, meaning they will move away from their original position, and then they erode the soil, and then they can be wider or they can flow in another direction. So to prevent all that, you have to install drainage. That's for river lah, and that's also for public lah. This is more towards city development. Okay, so typically before that, storm water is is originating from precipitation, meaning it comes off from rain. So there's two main issue lah when we have storm water, which is we want to control the volume and then the timing of runoff water, and then the other is potential pollutant or contamination. So next we have a typical fundamental of what a storm drainage is. So it's just a structure of network to remove storm water back to the pond, lakes, stream, or river. So in the case if we do not have a very good storm water drainage system, then we have flooding lah, which you can see here. So during when you have an area which is not very very developed, then we do not have a very good storm water drainage. That is not a problem. This is because we have a lot of open area. So open area meaning a lot of area is not covered with concrete. So this way, the rainwater, when it rains, the storm water, they can run off or be absorbed into the ground. But imagine if you are here in KL, that we have developed it until it's so dense. So once we have developed it to be very, very dense, we have building every corner in a very, very large area. And then when it rains, all these area are collecting water. So when it collect water, when all this area is collecting water, and then if you do not have a very good storm water drainage system, then flooding happens. This is because we are not able to effectively remove all the rainwater accumulated in the area. So all the pipes and then all the drainage pipes are there. Usually it's exposed. It's there to help direct away the water flow into either river or stream to prevent accumulation of rainwater. So this is why sometimes flooding happens lah if our drainage system is not good enough to cater for the discharge of this rain. So this one is depending on where we are at lah. So if you are at if our area is at a higher elevation, meaning higher uh, uh, with reference to sea level lah. So whenever we measured our elevation, we will measure it with reference to sea level. So if our area is higher than sea level, then we will not have, we do not care much about flooding lah, because water flows away from our area. But there will be some area, there will be at a lower elevation. So this is the area which is very important lah, to implement a very good stormwater drainage. If not, then you'll always experience flooding lah in your area due to that area being lower as compared to other area. So water will all flow towards that direction. Okay, so let's see. We have this is all about what I've just explained just now. So generally, when it comes to acts and regulation, is by our local municipal council regulation, or even harvesting rainwater harvesting guidebook. And then we also have our street drainage and building act to follow. And then we have our urban storm water drainage management. So usually when it comes to building public road drainage system, this is controlled by a local council lah. So local council decide how big of a drain it should be built. No worries. Okay, so just a general idea regarding why we need just a quick summary regarding why we need all this drainage system is, as we develop the city, as more and more building, then there will be less and less catchment area. So catchment area is exposed field lah, meaning you have soil. Once we do not, or once we have less reduction of this catchment area, then where does then all the rain when the rain happens, then all the water will not have will not be able to go back into the soil, so they have to flow into the drain. But if the drain do not have high enough of a discharge rate, meaning this drain, if they are unable to remove all the water in time, then they will start to overflow. So this is where flooding comes up. And then if our area, or if there's a very, very heavy rain, then this is bad lah for the area. So as we know, we are all in Malaysia. Malaysia is a tropical country. We experience high level of rain. So because of that, we need to have a very good drainage system lah. If not, that area would experience a lot of flooding. So as we covered more and more area with concrete, then we are effectively reducing the way how nature divert storm water. So yeah, as we develop building, and we covered the area to be nice and very accessible for us to traverse, meaning we can move around very nicely. We also we also does not allow water to go back into the soil. So we effectively reduce the amount of area, catchment area. So when it comes to private properties, we will have all these network of system lah. So we have our roof, and then from our roof, which is one of the catchment area for rainwater, you have gutter. This is to allow us to divert the rainwater collected by our roof either into a rainwater harvesting system with the help of a gutter and a pipe. So this is a gutter and a pipe, and then which can direct all the flow to the drainage outside our property from here. So same case with any building lah. So this is like a standard system. You have roof, and then we have gutter surrounding the building, and then we have a rainwater downpipe. So this is a downpipe lah, and we also call it a rainwater down. We can put in a rainwater, and then it's called a downpipe. And then we also can have a sump, depending if your building is very, very big, there will be a sump. So a sump is like a mini manhole where there will be an intersection of pipes. So this is like a small box where you have some intersection in between, then you put a sump. Okay, then after that, you'll go towards the perimeter drainage. So from perimeter drainage, then it will go towards the public drainage. So perimeter drainage is typically very, very small lah. You will have a U drain. So usually we install a U drain. That is a pre-cast brick type surface drainage, because when it comes to a small area of catchment, let's say for example our property on our house, then we do not need a very, very big drainage size because there's not much water. But as the water accumulates or progresses from one taman to outside the drainage, let's say in one taman we have about 100 building, and then from that 100 building, the accumulated water, they will have to flow out of that area. Okay, let me just go through. So this is like, this is before that. So this is the gutter. It can be called an eave depending on the material, or it can be even a box. So it can be concrete, or it can be like this also, but instead of plastic, there can be a metal box. So this is a roof drainage from roof towards the gutter. And then to flow it all out, we can have pipes. So pipe can be cast in. Okay, so pipe can be cast in. So this is typically how it's done in Malaysia, because it's ugly if you have something like this. And then when you have an exposed piping for our building, then there's actually a possibility of leaf falling into here. So when leaf fall into here, then we need to do maintenance. Same in case like this. So if you have exposed drainage, then we need to do some cleaning on it. But in most cases in Malaysia, all our drain are all cast in, meaning we have pipes into the roof, and then we have a opening here. So from this opening, because all this pipe is cast in, we do not want material to go in. We actually have an interceptor trap. So this is something that is up there lah, that pop up, that does not allow. This is a filter lah, that does not allow leaf to go into our pipe. So if we go into our cast-in pipe inside the concrete here, then it will be very difficult to clean. So this one is there to not allow lah, all the debris to go into it and obstruct the flow. So once a while, we have to clean it up lah. Okay, so when it comes to property drainage, we have a system lah, which is we can be open or closed drainage, and then we have pipes. Some it can even be a swale, but this one usually we do not use it lah. So we shall cover later on what is a swale, and then we can also have an on-site storage facility. So when it comes to on-site storage facility, this will be when we are starting to harvest rainwater. So in Malaysia, as I mentioned very briefly during our, let's say, water supply and sanitation. So rainwater, we call it grey water, whereas in sanitation, dirty water which is contaminated with our human waste, we call it black water lah. So collected rainwater is actually one of the good source of drinking water lah, but there's a problem with drinking rainwater because there's no mineral in it. So they are quite clean, and if you want to use it for drinking, then the idea is you do not store it for long lah, because once we store it for long, if you do not boil before we drink it, then bacteria will start to grow. So if we just collect it for a long, we collect it and put it there for a long period of time, then it's actually not so safe lah to drink, as opposed to us drinking it straight away when collected. So all this collected rainwater is free, so we can actually use it to water our plant, which you call it as irrigation. You can use it to flush our toilet and do any cleaning which does not require very, very clean water. So there's actually three main components towards rainwater harvesting. So first off, we have catchment. This is usually from our roof lah. So our roof covers a very big percentage of our property. So we use that as our catchment because it's not in contact with ground, and it's very less likelihood that there won't be any contamination lah. And then from our catchment, we have our conveyance, which is how we direct our flow of rainwater towards any filter and storage that we may have. So from there, then we have our catchment area on the roof and conveyance to to our tank. And then finally, we have our storage. So we actually need to have a filter lah, because all the rainwater we collected, sometimes there will be some debris which we need to filter up, which is leaf lah. So from there, after we have our storage, then we need to have a pump to move it to a water tank. So when it comes to storage or towards usage, instead of having a lot of pump, we just want to have one pump lah, which we can direct it to the top of the building to use as our water. So to use rainwater is actually quite a complicated process because we need to maintain the pump, and we need to install additional piping and component to ensure that no contamination or no debris such as leaf or branch go into our storage tank. So if they go into our storage tank, they will actually effectively they can damage our pump lah. So we do not want that. So in in addition to that, we also need to install additional pump. So it will cost a bit of electricity and upfront cost to purchase the pump and all the piping. So once you have that, you can have two tanks, one from the main water supply and then another one from our rain harvesting system. So this rain harvesting system, you need to work out uh, a system lah in which area of our house, which appliances will make use of our water of our this rainwater tank, and then which one will be using our main water supply. But then this is not the end of the system lah. We actually need to uh, make an overflow system also. So because here it just show you a simple idea of how it works, but then in real case application, when it rains, we do not we need to make an overflow mechanism, meaning once it keep raining and then our water tank is already full, we need to have a outlet which is able to allow the rainwater to just flow out from our system instead of overflowing from here. Instead of it's already full, so we need an overflow system or an overflow pipe to just allow the additional water to go out from our system. Okay, so when we harvest rainwater, there's a few benefit. Mainly is we reduce our water demand. We don't have to pay for water. So in Malaysia, when we pay for water, then it's from Shabas lah, and then we have less energy demand due to the water supply. Shabas, they do not need to distribute so much water to every household because we can use rainwater for watering our plant, irrigation, or for any task lah that is not that does not require usage of clean water. So one good thing about one of the main other thing that's not talked about is when we are harvesting rainwater is actually prevent urban flooding. So why does we say this helps in urban flooding? This is because we are actually containing the water. We are not allowing the water to go out into the public drainage. We are containing it within our own property to be used for, let's say, gardening, for example. So this way, if everyone were to implement this sort of system, then there will be less water run off from the property. And then from when there's less water run off from the property, uh, there will be less water outside. And then besides that, this is all additional There will be okay. So it's for irrigation, and then that's from water bill, and then there will also be another new job, meaning we can have more job So the main benefit is these three There will be lots of benefit besides that, but they will be interrelated Like for example, here is when we talk about less water demand, then it's also a good source of water for plant. This is more towards irrigation, and then we can reduce our water bill. So this one are all interrelated So there's actually a lot of benefit towards rainwater harvesting, but then there will be some disadvantage towards it because we need to install the piping, ensure you also need to have additional tank, we also need to have pump, we also need to ensure that the system is working properly. So we need to maintain the system. Okay, once this system or once this stormwater escape from our property, So it actually goes towards the public drainage. So in a case where this area they're catching too much water, and then they are discharging too much water. Let's say for example, we have a few properties in place lah, and then let's see. So let's see. Okay, like this. So let's say this is drain, and then we have A, B, and C. So A is already developed, B is already developed, C is developed. C is a new property developing. So because of that, A and B is already this they have been already, just for example sake lah, they have been already developed, let's say for 20 to 30 years ago. So all the drainage are already fixed. So now C is a new property that's being developed. So once a new development is decided, and then because the public drainage is already fixed due to township planning, so when we have a new development, which is C, after a lot of years lah. So because of a new development of C, then we need an on-site detention. So it can be based on properties. It can even be based on an area lah, where we can have an on-site detention. So why we need an on-site detention is because the public drainage is not catered to handle that amount of water being discharged from each property. So that's why you have on-site detention to hold off the amount of water in your property and control the output from that area. So this is to reduce also from pollution and flooding lah. They are placing a limitation on the amount of storm water. Okay, so this one is for property. Usually when it comes to on-site detention for a property, it'll be not a building lah. It'll be actually be a big shopping mall. So they will be collecting all the water to a tank, and then they'll have a small pipe restricting the amount of water flowing out from that property. So this is an idea of how an on-site or building detention system works lah. Okay, next one, let's go to okay, so another idea is when it comes to bigger area, then we actually will have detention pond lah. So as I mentioned earlier, the case previously mentioned was for a single property, which is usually a mall, where they cover a very, very big area. So because the public drainage is unable to handle that amount of discharge, so we need to limit it. Then the same case for when we have a big development. So instead of having big tank, we can make an artificial detention pond. So this one, it can be just a normal looking or a hidden detention pond, or it can even be made into a feature lah. Like we make it a big detention pond, we make it a big lake, and then we can have bridges and maybe a pagoda or something lah in the middle as a facility lah, or to make it a main point of the development of a new area, like what some developer have done lah. So a detention pond can either be a half wet type or a dry type. So this wet or dry type is as what is mentioned lah. Meaning if it's a wet type, there will always be some level of water. here for the pond. If it's a dry type, then this pond is designed to be dry when there's no water. So there will be in some case where because we are already making a pond, then as I mentioned, you'll make it into a feature lah. So this one is to ensure that this system is to ensure that we do not have too much water lah being discharged out into our already fixed permanent public drainage system. So because our public drainage system is already built in a very big area, we already built it up. So we cannot actually remove and install a bigger drainage because that will cost a very, very big amount of water. So to solve that sort of problem, if you have new development, let's say we build a new housing estate, then we install detention pond. If it's a big building like a mall, then we will have our on-site detention. So this is a difference between if it's for commercial development or if it's for a normal residential development. Okay, when it comes to development of road and transportation, then we will need to have hillside drainage. So this is when we are cutting through a very, very long path or very, very long destination from A to B, let's say from Penang to KL, then we will notice that there will be a lot of hillside drainage along the way. So it's actually divided into two methods, which is it can be natural or it can be artificial lah. But usually we do it in an artificial way. Okay, for structural method, you want it to have more lining required, and then we do not want to allow for infiltration, and then any drainage conveyance is fully lined. We want to have drainage, and then any big bioinfiltration are not allowed. We do not want to have any wet sediment on basin or wet pond. And then we implement a lot of stabilization technique. So for non-structural, we do not build anything lah. It's more towards allowing, it's more towards studying and allowing and making a very low gradient design. So when you are talking about hillside drainage, it's more towards, for example, roadside. So this one is more of a structural method where we intervene and we design the surrounding area to ensure that there's no erosion and to ensure the proper stability of the structure. So we build a road. We want to ensure the foundation, which is the soil, is kept in place. So if we do not ensure sufficient removal of the water or rainwater accumulated, or if you allow rainwater to infiltrate into the soil, then they will actually effectively weaken the soil. So to do that, usually we will want to intervene lah, meaning we want to intervene. We will put a layer of geotextile or layer of material that is able to stabilize the soil, and then we install a lot of drainage. We cut the slope, and then we plant vegetation. We also implement non-natural method lah to hold on to the soil also. And then we also installed hillside drainage also. So hillside drainage, such as this way, will allow water to escape from the ground. So usually when we install we call this a clog perforated pipe. This is where we have a high rain water, sorry, high water level. So for example, let's say we cut this hillside. So we can have a person standing here. Because we know this is unnatural, if we cut it like this, we can have a, let's say, building here lah. If we cut it like this, if our water level is here, then this is dangerous lah, because this area is all very weak due to the water level. So they will weaken the soil surrounding and cause it to collapse. So to solve or to reduce the water, because water causes the soil to weaken, we install pipe. Let's say, for example, we want to reduce the water level. So we install pipe. So this one is like this lah. We just install pipe along a section all the way. This will actually reduces the water level by quite a lot. So it will be high on some place. It will be high the further we go, but when it comes near to the wall, it will actually drop down lah, due to us having a perforated pipe. So how does it look like? Let me show you. So yeah. So it actually just looks like this. So it's a HDPE pipe. So usually we do not buy pipe with hole lah. So this one hole is, this all small hole is what we on site we drill out by ourselves. So we just take a drill and we can drill into this HDPE pipe. And then to ensure that our pipe does not get clogged, then we can cover it with a material which is what we call a geotextile, to ensure that nothing goes into our pipe lah and clog it up, to allow a good flow of water. So this is how this can be how our pipe can be buried into our ground to allow water to escape from the surrounding soil. Okay, so an idea of how it's like. If we, this is just a reminder lah to you guys that when soil is dry, typically they are very strong, meaning it's not easily compressible lah. So a soil, if we were to look at it when it's dry, there's actually a lot of void lah in it, meaning there's actually a lot of microscopic small hole inside it, or air gap. So when we wet it up, then all this air gap is actually filled, and then it becomes compressible lah. The soil loses a lot of its strength. So this is how our ground is like lah. So that's why when we have a building, we do not want to build a building, the foundation, close to a very high water level area, because that is a very weak area. So for a building to be stable, the ground needs to be soft, so that we can anchor towards the ground and the building is stable. So water is a very bad lah towards a building. Okay, so besides that, in addition to all this hillside drainage, we also want to drain away our water from our subsurface, meaning below our ground, that we also want to remove away water. So this is to increase stability of the ground and footing of the building. and foundation movement. So if the soil is wet, then there will not be contact. So let me just quickly draw something. So if you have a building here, if the ground is wet, we will lose our footing, meaning our grip from we will lose our grip, our footing will lose the grip with the ground, and then there will be movement. So when a building have movement, then it will be very bad because it will affect the stability of our building. And also if the building decide to go left and right at the same time, then we will experience crack all over our building. So we do not want that. That's why we want to ensure that there's not. That's why we want to ensure that not a lot of water infiltrate into our surrounding building. That's why we covered our property with concrete. So we do not want water logging. So mitigate surface water ponding and water logging of soil by lowering water table. We want to elevate the groundwater pressure. This is for our foundation to reduce any accumulation of water surrounding our foundation of our building, and then reducing the moisture content. So as I mentioned, when the soil is dry, they are actually very strong. But when they are wet, they actually lose their structural integrity, meaning they do not hold well. So to drain our surrounding or our soil, we also be using the same perforated pipe So we have the same perforated pipe. We installed it into our ground, and then this will allow water to be absorbed from the surrounding out to the direction in which we want our pipe to be. So we can have a building from the top view. So we view it from the top. We can have pipes across our building in a sloping manner, in a sloping gradient towards a outlet. So we can have towards a public drainage outlet, which is this is from our perimeter drainage. Let's say this is our perimeter drainage. So we can have our subsoil drainage across our building in a sloping manner out towards this direction. So this way, any water or if this area has a very high water level, they can be drained out from our property out towards the public drainage without affecting the foundation of our building, which will weaken our building Means it will destabilize our building and then cause cracking on our house. So there's a few configuration of how it can be done. We can just have a basic system which we fill it with material that's porous, which is stone, and then we can upgrade it. We have it with a geotextile filter, meaning we put geotextile in it, and then we go up higher. We can have pipe drainage. We can even have a pipe drain with capping. So this is to ensure the surface water do not flow into it, where in this case the surface water can be flown into this. And then besides that, we can have geotextile around the pipe or this. So we can have different configuration but usually unless our building is very deep or is prone to very high water level, then only we will install this sort of methods to ensure that not too much water is accumulated underneath our foundation. So usually for our residential building, we do not care about this thing typically. So by right, if you want to make sure our building is very safe, we want to install this subsoil drainage underneath our building to ensure that water do not accumulate and cause the soil to weaken around our foundation. Okay, so when it comes to public drainage, it won't be the small. Let's see, I just show you. Okay, by right it should be okay. So it's a concrete. There's actually a drain. Okay, this one will be more towards the commercial size. Okay, so typically lah, when we comes towards our public or our normal residential property, we can have precast concrete drain, or it can even be from clay lah, clay drain. So when it comes towards this one is a very small size lah. You can see the depth or the amount of rainwater that it can divert is not a lot because it's not so big. But when it comes to bigger or more public drainage, then we can have a very deep size such as this. So this one is not next to the building lah. It's more towards next to the road. So a road will be very very long in direction, meaning it needs to be very deep, and then it's also collecting rainwater from the other taman also lah, a property, a development. So then after that, from here, we can go to even bigger drain. So for example, let's see. So for example, when in KL, we can have a very big drainage. For example, we go towards a river of life. Yeah. So this is uh, our commercial drainage. When it comes towards diverting most of our water in our city, then we have a very big covered. So, I mean, you see, if you look at it here, then usually we have some water lah flowing through. So this one can be due to river water, and then additionally, when we have rain, then all the water can be diverted into here lah. So there's actually two levels. So it can be open or it can be swale. So when it comes to open, it's all man-made lah, meaning we have concrete precast drainage. We call it a pipe or even a box covered, depending on the size and the material. So these are there to facilitate the major drainage. And then swale is a man-made natural feature lah, or drainage. So this is what we call a swale. So here, when we have a line drain, this is very good because it's high resistance to erosion. It can last for a very very long time, and we do not need to maintain it. So they can be made from concrete, stone, or brickwork, plastering, or masonry block. So an open drain will be something like this, and then this also can be a U shape or it can be based on this is precast and then this one is based on cutting and laying down a block lah. Okay, so when it comes to either open drain or closed drain, the only requirement or idea behind why we want to close off a drain is because there is pedestrian traffic. So a pedestrian traffic meaning people will walk by the drain. So that's why we need to cover it. So this one we will encounter it in places near a building lah. But when it comes to here, uh, perimeter drainage, we might not cover it because this is not an area where people always move about. But in a building, then you'll find that most of our drainage is covered up. So this is a difference between why we sometimes want to have open or maybe we have closed. So we want to have a closed drainage. This is due to the reasoning of uh, safety lah. So we do not want people to trip or fall into this drainage. So this is more towards a safety issue on why some drain might be covered and some drain might be closed. Okay, so next will be we have swales. So this one is designed to. This is just a broad and shallow channel to remove off runoff at a non-erosive velocity, meaning this is a man-made artificial natural drainage system. So water quality can be removed through infiltration, sedimentation, and filtration. So a swale is a man-made artificial some sort of a channel where we have vegetation, which we can use it to trap any debris, and then to ensure that all the rainwater can be diverted away and be allowed to infiltrate back into the soil. So it will look good because it looks like natural. We can trap away any pollutant, and then we can reduce the runoff rate, meaning because we have so much vegetation there, the water will not be able to flow so fast, and then we have low capital cost and any maintenance because when we have grass, we need to cut and we need to remove any rubbish can be incorporated into maintenance. So one of the disadvantage is there is maintenance fee to work out on, and finally we can remove any pollution and blockage. So the disadvantage of this system is that it's not very suitable for steep area because we need a very big area to cut and plant the grass, and then it's easily blocked when we are connecting it from. Okay, so it's easily blocked when we are connecting it from from the swale to the pipe work because of all the vegetation and all the material, and then this is also a very big drainage. The swale is a very big drainage. When we're trying to connect it to a smaller pipe or culvert, then all the rubbish or all the pollutant can easily block the pipe work. And then to incorporate the design, we need a big land. And when it comes to swales, because most of it is vegetated, meaning we have a lot of natural material, we can have a problem of the safety, odor, and mosquito problem So depending on our area, there's not much choice when we start to develop in our city. We can either have a artificial looking drainage, which is what we saw here, or we can have a natural one. But then this will come with its sets of problem lah. We need a big area, and then when we are connecting it from natural looking swales to artificial drainage, then there will be problem lah associated with it. So we also can have underground pipe drainage. As you can see here, underground pipe drainage. So all of this will be diverted into a sump, and then it will be out into either a pond or the river lah. And then we can have a covered. So a covered is in the case of we have a structural built upon it, and then we need to divert the water. It's just a short length of conduit lah, to transport stormwater through an embankment. So when we have when we need to build something on top of across the river or any stormwater, then we can provide a covered. So a covered can be in terms of a precast, RC precast covered, or it can even be a pipe covered. So this way we allow the stormwater to travel across this structure through a very short distance. Okay, so finally, we have our engineered channel lah. So this is still our public drainage, but this will be in terms of a bigger capacity. So when we talk about a big drainage system, you want it to be engineered lah, in terms of being able to flow. So imagine if you have a very big drainage, this big drainage or big size drain will not be able to effectively remove or will not be able to effectively drain off small amount of water. So to do that, we actually engineered the channel to have a small channel within it, so that it allows uh, a good flow of water when there's a low season of rainwater. So this is the idea behind designing a engineered channel with a smaller drain size at the bottom to allow water to consistently being able to flow out. So we call this an engineered channel. So typically this sort of design will be found in this lah. So if you notice here, at the bottom at the bottom of the drain, there's actually a very narrow drain. This is to allow a constant discharge of small amount of rainwater out from the drain. So if you do not have this sort of small channel, let's say for example, okay, it's a bit ugly. So let's say for example we have something like a square. So if we do not have let's say for example we have a square instead of this engineered channel. So if we have a bit of water here and there's no channel at the bottom, then the water will not be able to flow properly. So when the water is not able to flow properly, then there will be ponding of water lah. So we do not want that. So this is the reason why we engineered a channel to allow for a low design flow. So this engineered channel will be able to serve two function lah. When there's a major rain, then this big major drainage will work to remove the drainage. But then when there's a low season of rain, then the minor drain can provide a safe passage for the water. So the idea is behind that lah, having a big drain and also a small drain inside one system. Okay, so I think that will be about